Hello, well, first things first is a little bit of background information you need to know before you learn about electron configurations. Right here is an electron. These are electron orbitals. You have your s orbital, p orbitals, d orbitals, f orbitals, but S and P and D are the only ones you need to worry about because that's what the state of California requires us to learn about. So, those are the orbitals. Take a mental note of that. Hello! Welcome back. So now that I told you about orbitals, it's time to learn about electron configuration. Whoa! Exciting! So as you can see, we have S, P, D, F, as I told you in the orbital section, but there's like 1s, 4d, what does that even mean? So, here we go. So we can, the S, 1s, 2s, 3s, 4s, so on, S orbitals can fit up to 2 electrons, while 2p, 3p, 4p can fit up to 6 electrons. But wait, there's even more! 3d, 4d, 5d, those can fit up to 10 electrons. That's a lot of negative energy right there. Don't worry about F. And as you can see that the more orbitals you have, the more energy. Also, not shown in this picture, but across the x-axis, if you go right, the atom increases in size. So let's take oxygen for example. Oh, I want to find what orbitals the electrons in oxygen have. Oxygen has 8 electrons because it's number 8 on the periodic table. So, we go down arrow, up arrow, 1s, 2. Same thing on 2s, 4. And then up arrow, down arrow, up arrow, up arrow, up arrow on P, so 2, 4. So you use 1s, 2s, 2p, and 2p. You want to make sure that for the p's and d's, that you want just an up arrow on each line on the diagram, because the electrons like to be far apart from each other because they're very antisocial with that negative energy. So now it's time to learn about the periodic trends, the hottest trends you will find. Hey kids, now it's time to learn about the hottest periodic trends in the history of the universe. So, everyone wants to know, what element is the bigger element? Well, guess what? Here's the easy way to remember. Lefter is larger, as well as down is bigger. That's what my chemistry teacher used to say. Let me just move this fire. Ow. Alright. And as you can see in this periodic table with arrows, the atomic radius goes bigger when you go left, and it grows bigger when you go down. So as you can see that, well, don't worry about hydrogen. Hydrogen is small. Helium is really small. But if you go all the way to francium, that's one big element right there, folks. And that's not it. There's even something more special. Oh, the person has a bigger atomic radius. Who cares? It's all about being like the noble gases and having a full valence electron shell, which is 8 electrons. As you can see here, that electronegativity, also known as how bad an element wants valence electrons, you can see that it increases as you go right, and also increases as you go up. So as you can see, fluorine is one desperate element that really wants that valence electron, while francium is kind of, I don't really care, because francium only has 1 valence electron, while fluorine has 7. So close to winning that full valence electron shell. And similarly to electronegativity, there's another thing called ionization energy. You might sit there and just think, wait, I don't remember that. Well, ionization energy is basically how strong an atom holds onto its valence electron. So, ionization energy grows stronger when you go up the periodic table and right on the periodic table. And also, to go back to electronegativity, noble gases, they're so cool already. They don't need any more valence electrons. Don't ask. They just don't need any more valence electrons. They already have 8.